on behalf of my colleagues here in New Zealand and my colleagues in Redmond. Thanks for having us and making the time. I got to thank the local team for kitting me up properly for being here in New Zealand. I thought I'd spend most of the time today with my colleague Orville just going through sort of where we are on the AI journey, what are the things Microsoft's focused on, what do we see in the industry, and with that sort of mix in some demos, some videos, and try and make it interactive and fun. Making sure the machine is ready to go and alive. So while he's getting started, as Michelle noted, I've been at Microsoft for about 24 years. So sort of grew up in the industry and in our space. The building blocks we've had for the last 20 plus years have been pretty fundamental for everybody. Compute, storage, networking. When I got started, let's see here. Make sure they're alive. Gentlemen, you're gonna have to work on this. There we go, okay. When I got started, you know, compute was about a 286, and we thought about, gosh, I can't wait to get a 386, and from 386 to 486, and 486 to Pentium. So we're in good shape on compute. As we got more compute, we wanted more storage. And so 5.25 inch disk to 3.5 to, if you're old enough, you'd remember an iOmega drive that you plugged in the side. And so storage, we're in pretty good shape. And then, of course, bandwidth. From dial-up, which was super painful, to at least fixed broadband, and then ultimately 2G, 3G, 4G. Now the conversation's all 5G. And those three building blocks have allowed us to sort of go through multiple eras, from sort of client-only to client-server to internet to cloud and mobile. And that's sort of the conversations where we've been and where we are. The generation coming out of school today will have a new set of building blocks. There'll still be compute, storage, and networking. But they'll have AI, they'll have IoT, Internet of Things, they'll have blockchain, they'll have mixed reality. In a couple of years, they'll have quantum computing. And so you think of our journey in 20 plus years and the transitions, just think of that generation coming out of school and the set of building blocks they get to work with and how much things will transform. And so we're really at the beginning, in many ways, of the next phase. Now, one of the critical or timely conversations of those building blocks is artificial intelligence. And AI isn't new. It's not a new conversation. There's three things, though, that have sort of moved it from a very specialized set of folks working on it in a narrow way to essentially, everyone in this room and all over the world, every developer, every data scientist, every company that I meet with wanting to have a conversation on AI. The first is that compute, storage, and networking at scale. The sort of cloud availability, be it us or Google or Amazon, means that every developer, every data scientist anywhere on the planet can get access to the scale they need if they want to build models, if they want to run models, train models, build deep neural networks. And that just didn't exist before. The second thing is the growth of data. Data is the fuel for artificial intelligence, and whether it's human-generated data on social networks, on Twitter, et cetera, or machine-generated data, starting with PCs, then mobile phones, then IoT sensors, we have more data than we've ever had. In that space, we have some unique assets with Bing and LinkedIn and what we learn from our own products. Others do as well. But that growth of data is the second area. And the third, frankly, is just pure research. There's been a lot of sort of core research over the last 25 years. I tell people I did my first speech recognition demo, I think around 2002. We're still doing speech recognition demos. I mean, we're still learning. The research is there. But it's moving faster. 4 years ago, there was a contest for image recognition. At that time, deep neural networks could go maybe 10 layers, maybe 20 at the top. Research team got to 152, I think it was, 154 layers, and won the ImageNet contest. That was 4 years ago, and sort of image recognition has sort of gone through the roof. Speech, we passed sort of human parity for speech recognition about 3 years ago. Us and IBM and others sort of go back and forth. There was the Maluba team in Canada. Kind of sounds goofy, but beat Miss Pac-Man about 2 years ago. And while winning at games maybe not super useful, the AI tools and techniques they used for sort of essentially breaking a job up into multiple pieces and multiple agents, which is how it beat Miss Pac-Man, very useful for things like customer care or routing systems. So that's 2 years ago. About December, us and Baidu sort of beat the machine reading sort of squad test, sort of human parity. And again, these are narrow tests, but that one popped along. I think it was last week now, sort of speech recognition, Chinese to English translation equaled human parity. So you just see the pace of the research sort of increasing and actually the use of it across multiple domains moving forward. And that's allowing essentially a set of tools to come into play that allow developers and allow data scientists to start to integrate AI into everything they do. There's a good quote from Satya here, our industry does not respect tradition, it only respects innovation. So the innovation side and that research side, Microsoft's had a research center for about 25 years now. And that's, if you look at where we have AI today, AI and research are put together because there's still so much fundamental research that's core to this that as we think about building solutions and platforms, we also think about how do we fuse that with the research that's ongoing. Now, based on the background, then what are we doing? What do we spend our energy on? And at Microsoft, we really do three things. We're sort of plumbers, software plumbers by trade. We build platforms for software. We have a platform for devices. It's called Windows. We built some devices, HoloLens, IoT devices, etc. We build a platform for the cloud. It's called Azure. Has some data centers. We build a platform for line of business applications, Office. It's also a heavily used line of business applications, Skype, etc. And now we have our fourth platform area, which is the artificial intelligence platform. And we're early, so I'll talk a little bit about that. The second is we're starting to infuse AI into our own products. And my own view is if you do a good job, nobody knows, they just work better. You don't say Office now with AI or Windows now with AI, just it works better on your behalf. And then last but not least, we're starting to work on a new generation of business solutions. How do we take sort of the data assets and the platform and some of the scenarios that people are interested in and start to stitch them together to think about end-to-end solutions. And so we'll sort of walk our way through these over the course of the morning. On the platform side, it all begins with infrastructure. As I spoke about, you need the cloud as a core for scale. You need to be able to work with data. And it doesn't matter whether it's sort of Windows-based or Linux-based, open source or not. We work across all the tool sets. And we work all the way from sort of the chip level up through the cloud level, up through the data level. And it's important because you need incredible optimization at all levels if you're going to start to run AI workloads. And as an example, there's a lot of work that goes on actually at the chip level. We're all familiar with CPUs, sort of the most general of the processing units, GPUs, which give us graphics processing units, more acceleration. There's something called field programmable gate arrays, which are even sort of less flexible in some ways, but can be optimized for much higher efficiency. And so that work at the silicon level is part of the entire stack that we're working on to sort of bring AI to life. This one's kind of interesting, so we thought we'd do a quick demo of it, and I'm going to invite my colleague Orville to come on stage, and he'll do a quick demo to show you sort of the difference between CPU, GPU, and FPGA. So Orville?
So I'd like to start off by saying good morning, Auckland. I hope everyone's having a good day, and thank you for welcoming us here at AI Day. It's estimated by the year 2020, the world is going to have 44 zettabytes of data. So when you look at something like that, it's a pretty big number, and if you're like me, you do a little research to figure out, well, what exactly does that mean? And that actually translates to roughly 6 terabytes per person. Not adults, not kids, every person on the planet. To give you additional perspective, if you think of your smartphone, if you're like me, you're traveling on the road, you have pictures of your kids, videos, work email, favorite apps, and all that sits within 128 to 256 gigabytes. So we're going to be awash in a lot of data. And if we want to make the dreams of AI real, it also requires some changes in hardware and the way we compute if we're going to actually crunch all this data. So here I'm going to show a quick test. This is going to test out a CPU, a group of CPUs, a bank of roughly 24, and FPGAs, just to highlight some of the differences we're starting to see with advances in hardware. So I'm going to start with the CPU. I'm going to go and run a test. And you're going to see that this is going to move relatively slowly. You see that we have a latency of about 442 milliseconds. And each dot represents kind of the throughput of the transaction. CPUs, single instruction at a time. Now we're going to actually take a bunch of CPUs and we're going to go and run them in parallel. Let's take a look at the difference. You can see it's a lot faster. We've gotten about 1/8 of the latency. You see the throughput really pushing through. However, if we're going to really crunch 44 zettabytes of data, we need something even greater than that. And for that, we have FPGAs, which stands for Field Programmable Gate Arrays. And the way you could think of it is that they're semi-flexible, but unlike a CPU that's a general instruction set, we could optimize it for AI tasks. So I'm going to go and I'm going to run the test on the FPGA. And you can see that just shoots through the roof, 15 milliseconds, lots of throughput. So you can see that at Microsoft, not only are we thinking about the algorithms and the way to make crunching this data a lot faster, but we're also looking at advances in hardware. And I can only imagine what all of you will be able to do once we start getting quantum available and other technologies like that. So for that, I'll bring Steve back out.
All the way over. So that's infrastructure, and we'll continue to work on infrastructure. You'll see more services in Azure, sort of global scale, all of the work that's going on sort of in the data lake area, Cosmos, so just growth. And my understanding is New Zealand will grow a 20% CAGR in terms of public cloud in the next couple of years. So this is a worldwide phenomenon. We need to just keep investing here and add value. The second layer above it is, what are the things that are more unique specifically to AI that sit above the cloud? And there's sort of, I put them into three buckets: cognitive services, custom services, and then sort of conversational AI. The cognitive services are essentially human cognition. How do we add sort of the ability to reason over information, to see, to hear, to understand, and build those as a set of services that then can be infused into applications or services or experience that you're building as a developer. And so image recognition is a good one. We have a very large training data set of information that comes from Bing. It allows us to train all these cognitive services, so we can build a entry-level sort of cognitive service for image recognition. So then if I'm building an application, I want to be able to recognize things, let's just say animals, I can build the application for that, and if somebody holds up a picture of a giraffe in front of a computer or a phone, you can say, oh, that's a giraffe, and if you hold up a cow, you can say that's a cow. So that's the starting point. The second thing then is to make them programmable. What if I'm trying to build the veterinarian app where they don't just want to know it's a cow, they want to know what type of cow it is? Well, we don't have that level of depth sort of in the work that we do, but experts do. And so at that point, you can actually train your own model for cows and have cow recognition and create a REST endpoint and build that into your application or service. And so in that way, be able to customize the cognitive services. Same for speech. If you're trying to use speech recognition for sort of a standard conversation, not too much of an issue. If you're working with doctors or you're working with lawyers, or you might argue on the computer side that we all have jargon or acronyms that we work with. How do we sort of train the model to know that particular acronym set or that particular vernacular that an industry uses? So it's not enough to just have the core cognitive services. We also make them trainable so they can be used in any scenario. And there's lots of examples of people putting these to use today. The second part of this is, we call it the bot framework or conversational AI. And we can argue whether the conversational interface itself is sort of AI or a sort of natural interface. But as we think more about artificial intelligence, and we look at the long tail of applications we've had, the notion of a conversational interface is the direction this is heading. And so whether it's typed in or spoken in, this idea of having a super long tail of apps, on my phone or any device, versus being able to just ask a question in whatever sort of app or experience I'm in, whether it's Facebook Messenger or Skype or Slack or SMS, I just want to be able to have a conversation and get the information. If I'm flying home on Air New Zealand, I might not want to download the app since I don't come here that often. Maybe I just want to ask about my flight. And so that notion of a conversational interface is growing. And so one of the things we've been working on is, how do you build a front end so I don't have to create a separate experience for each of the canvases or each of the tools that are out there. I'd like to write my sort of conversational interface once and then have it show up on Slack and Skype and Facebook Messenger, etc. So that's what a conversational interface or the bot framework is. So now I have a set of cognitive services. I have the ability to create a conversational interface. The other part of the tool chain then is sort of custom services. So a big chunk of what's needed in the beginning of this is the data side. And data, for all the progress we've made and all the data we've created, is still super painful to work with. There's a lot of it. It's not well organized. There's a lot of cleansing that has to be done. It's not managed like software. And so we're starting to work on a tool set that makes it easier to clean data, to manage data or models more like code. So if I want to have a regression on a model, I want to share models, we can think about them and train them more like code going forward. And so both for the data scientists that we're working with and with the developers we're working on, we're starting to build this layer of tools that sit above sort of the cloud and Azure and sit above the data that are more specific to infusing AI into experiences. Let me give you an example of that. I've got a video where we sort of start to bring together some of the cognitive services into a complete experience. So I'll go ahead and run that.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind. and that's where it was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do. But artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
So it's nice to see the progress on some of the solutions in bringing these pieces together. I thought I'd ask Orville to come out. This is a real app that's available today that we continue to iterate on. So I thought I'd have him show you a little bit of the work we were playing with it here in New Zealand. And so I'll ask Orville to come back out and do a quick demo of this.
All right, thank you. So one of the things that I love about AI is, well, first off, I'm a bit of a nerd, so I love like the algorithms and digging into it and stuff like that. But even more importantly, I love the application of it to society. Since I've been here in New Zealand, we've done a bit of a tour across Singapore, Sydney, and here, and I've just been playing with this app everywhere, and it's been wonderful. It takes advantage of both the intelligent edge, so running models on the device, but also leveraging the cloud as well to fill in where there might be gaps. So I'm going to actually show you a quick demo of it here. And this is going to be inside of a hotel room.
130.
So you can see that as you're going through in real time, it's actually taking a look at the environment. And then as it sees short text, it's picking it up. So if you think of being visually impaired, you don't have time to say, click, and take a picture. So it runs the models in real time on the video. Not only does it work well for short text, but it also works really well in identifying products. And I must admit, I probably annoyed the local team a little too much because I kept going to the refrigerator and taking cans to go test it out to see where it would break. And here's a quick example with some soda. You can see as we turn the can around, we find the UPC code.
Coca-Cola 6CT.
So you're able to go through and be able to take a look at devices or different objects kind of throughout the world and get insights into it. You think that could be good, for example, if you're in a purchase experience. Another thing is around people, right? People are all around us, and sometimes it's kind of hard to tell who's around you. So you could do different things, like if you want to recognize a person consistently, you could take a look at their face on different angles. So that way, kind of as you're walking around and you see your mate, so for example, if I see Steve, right, it would be able to tell me in real time, like, hey, you've seen Steve. But then there's other times where I'm meeting somebody for the first time and they're a stranger, and I want to have some insights into who that person might be. So you can see here you walk into
One face near center 5 feet away. Eugene near center 5 feet away. Process. 37-year-old male with a mustache wearing glasses looking happy.
who isn't happy to have their picture taken as you kind of walk into the room? So you can see that this is just like a few small examples of the great things you could do when you combine AI both on the edge and power it in the cloud with cognitive services to create wonderful experiences. And I hope after this event, all of you open up your compilers and start writing some great apps yourself. Thank you.
Thanks, Arthur. It's good to get a sense for these pieces are starting to come together. We're still early in AI in the journey. And so, the all singing, all dancing, it does everything not there. But real world applications and scenarios are starting to come together. One of the things that I think about as we do this is as we start to look at some of the scenarios and solutions, the notion of sort of the intelligent edge to balance the cloud becomes more and more important. It's one thing to sort of send everything to the cloud and do the training and build the models. It's another to run everything there. And so one of the things we've been working on is how do we get balance or some symmetry as we do this. The tools for building the scenarios exist. We'll weave them into Visual Studio. There's the Azure Machine Learning Workbench and the Azure Workbench overall. We have cognitive services. There are other deeper tools, whether it's CNTK or TensorFlow or Caffe or Chainer, and they're all sort of evolving and moving forward. And in that world, one of the things we're trying to do is sort of build a developer model. If you think of sort of DevOps over time, there'll be AI ops. And so sort of bring the pieces together. So we start with a tool chain. There is model deployment now, and we're starting to think more and more about the edge. There is something called the Open Neural Network Exchange. So over time, I don't have to sort of know sort of every different modeling tool, CNTK or Chainer or TensorFlow, and then the map to every chipset. Over time, you want some abstraction there. So we're starting to see these abstraction layers come in that'll make it easier for us to work with multiple different sets of chips, multiple different sets of tools, and then the ability to ultimately push a model out to the edge, whether it's Windows, Linux, Apple. We're going to be able to run these. So if I take that scenario that Orville just showed, we want to be able to run these tool sets, most likely in containers at the edge, all the way from very lightweight Android devices up through sort of secure managed Windows devices. And so that extension of the conversation from just cloud, which is sort of where a lot of the AI conversations have been over the last 2 years, to cloud plus edge is moving forward. And you'll see more and more work, I think, in this area, both sort of deployment to the edge and then tools like Onyx to help us be more versatile in terms of how we work across multiple systems, multiple tool sets, multiple chip vendors, multiple devices. Now, that's all platform, right? From the cloud infrastructure to the cognitive services, bot framework, tool sets, et cetera. The next thing that we've been spending our energy on is infusing AI into the products we build. And so this sort of occurs at all levels, a lot of it behind the scenes. So if you think about the load balancing and quality of service and running of Azure across all of the continents around the world and across all of the work we do, we use AI on the back end for that. Same for Skype. If you think about threat protection for Windows, both on the client side and then Azure on the cloud side, we use AI for that. If you think about sort of spam detection and filtering for email, there's just a set of work that goes on in the background. Sort of in the front, if I take a Windows device, if the inking is smooth on a Surface device or an OEM device, part of that's AI. If the keyboard gets slightly larger on a soft keyboard as you're typing because it knows what you're going to type, that's AI. If I take Office, there's a number of areas where we're weaving it into Office. If I take sort of a word program, the little squiggly underneath a misspell, that's not AI. The little squiggly under grammar, not AI. But now it'll start to look at a page of text that I've written and say, hey, it doesn't say Steve yet, but it says, hey, that third sentence in the fourth paragraph doesn't read so well. And by the way, it looks a little bit like this other sentence in the second paragraph. So here's some suggestions on how to change it. That's AI. And by the way, it's starting to do that to me. It's a little like having my wife or my mom sort of looking over my shoulder when I write because I'm not that good at it. We got to work on that piece to give it a friendly, Steve, you could do this more nicely. But it's starting to come into that realm. The same with PowerPoint. If I lay out a bunch of images, it'll give me 3 or 4 different ideas. It'll give me different color shading across how they can be laid out. It'll say, hey, here's some potential titles or captions for it because it uses the image recognition. And so we're starting to infuse it into the products. Let me pull up a different version of PowerPoint here. So here's a version of PowerPoint. One of the things we've worked on for a while is this notion of language understanding, from that speech to text, from that translation. And so in Skype today, you can do real-time translation from one language to another. Well, we can start to deploy that into Office, into PowerPoint. So if I go into here, slideshow, there we go. I want to start subtitles. So here what I want to do is just turn on subtitling. And so if I start subtitles, here I can pick a language. Let's go to English, so we'll just start this to get a sense. We'll hit next. It'll create a QR code, so if people in the audience want to follow along, we could do that. It takes a couple seconds to get started. And then once it gets going, it'll do the translation real time as I speak. And so now I don't have to have somebody else doing the typing in the background or doing the automatic translation. It's just off and running. Pretty handy, quite useful. Now, take this to the next level. I travel a lot. Let's assume, let me stop this. Stop subtitles. Let's escape. Let's do it again, but this time, let's pick a different language. And so now if I want to do translation as I'm traveling, let's pick Fijian. I'll hit next. Brings up my QR code. And then off we go. And it'll begin to do the translation. And so let's get it started here. Pretty interesting tool set now. When I went to Japan, I tend to speak quickly. There's always somebody trying to translate in the back of the room that's going like this, slow down, and I'm bombing along. And so I've tested this in Japan. I've tested it in Sweden. And most of the feedback from the audience is pretty good. Not 100% yet, but pretty close, and getting better all the time. So this is the notion of infusing AI into the products. We can do the same now with video. We can take a video, we can sort of do all the transcription, we can do translation, we can look for sentiment of the speaker, gestures. So there's a vast set of work that's going on in this area. Let me go ahead and stop this again. One other handy tool in all of this, of course, it's one thing to do the translation. We run in over 100 countries. So when we create a slide deck and send it out, every country then has to go and translate it, which is pretty painful because good or bad, we create a lot of content. And so here, not only can I do the subtitles, but I'm actually going to translate the slides. So we'll go English, let's pick Fijian again, and we'll translate the slides. And I will save this, believe it or not, I have done this before, so I will replace the existing version. And there we go. And so real time, this slide, the next slide. So incredibly powerful sort of tools now just weaving their way into the products, and we're doing this across the company, across the board, different scenarios in different places. But I like that one. I like the real-time translation, very useful, built right into the product. You can download it and use it today. And so again, these are the startings of bringing AI into the everyday products that we use or build. I did that. So last area to spend a little bit of energy on is the notion of building solutions. Now, for line of business solutions, traditionally we think of forms over data. And so that's, I don't care whether it's CRM or customer relationship management, ERP, supply chain management, et cetera. This notion of building a layer of intelligence now that sits above the system of record and below the system of engagement is growing. One thing we don't want to do over time necessarily is sort of infuse AI into all of the line of business solutions we have, but not then be able to share across. And so we're at a point where we're starting to think about what's the layer that sits in between, and we think more about sort of having knowledge over intelligence as opposed to sort of forms over data. And so lots of examples of this starting to come along. And when I think of sort of the patterns that we see in conversations with customers, these are some of the core patterns. The first one is this notion of virtual agents or business agents. Whether it's a business to employee function, let me ask HR questions, let me ask legal questions, let me ask IT questions. Or whether it's sort of business to consumer, let me help my customer care system by having a virtual agent start to answer questions. That is a clear trend and pattern in AI. We have lots of conversations in this space. The second is this notion of tracking people and objects in space. So the simplest example is I walk up to a building, we're working on this as well, it recognizes my face, the image recognition would be before, it lets me in, so security. Something happens, earthquake, did everybody get out? So that's sort of a simple example, that's tracking people. Tracking people and objects, take a warehouse or manufacturing scenario, forklift coming down the aisle, Steve coming down the other aisle, let's make sure forklift doesn't run Steve over, so safety is an area we get a lot of interest in. In manufacturing, quality control. The third one is retail. I walk into a store, pick up some items, it knows what items I picked up, I hand off one or two to Orville, it knows I handed them off to Orville, I put something down, it knows I put it down, it keeps track of the items that I'm picking up as I go along, and whether it's real-time couponing or automated checkout, that notion of creating an experience based on tracking people and objects in space is very, it's a hot topic right now. Given the neighbors we have across the little lake in Washington and what they've been doing with Amazon Go, there's a ton of interest from retailers. As opposed to building sort of new stores from scratch, how could we retrofit our existing ones with this type of capability? So that's an area of a lot of interest. AI assisting professionals. So how do we help with forecasting? How do we help with marketing? Medical is a huge field, whether it's radiomics or genomics or working with the doctor-patient in terms of keeping track of the information. How do we use AI to assist doctors? How do you use AI to assist lawyers? So this notion of using AI to assist professionals is a conversation, again, a hot topic area or topic area for AI. And the last is autonomous systems. People automatically go to autonomous vehicles, but there's also the notion of our networks, so autonomous or self-healing and self-managed networks. There's process automation. So there's a number of patterns that we're seeing to start to see emerge. Now, building these sort of end-to-end systems still requires a chunk of work. We've spent some time on the customer care side, so take the virtual agent. If you were to build a simple virtual agent that can answer questions based on sort of the platform, what time does Microsoft open, what time does it close, how do we get there, what's on the menu, that's reasonably easy because you can program the dialogue. When you want to do customer care, right, somebody types into the chat box, hey, I can't log on to my computer. Oh, Windows, Office, or Skype. Windows, oh, okay. Windows 7, Windows 8, or Windows 10? Windows 10, okay. Did you try this? Yes. Did it work? No. Did you try this? Yes. Did it work? Yes. Good, reinforcement. Did it work? No. Let me hand off to a human, take all the information with it, and sort of do that warm transition. You don't get there by programming a dialogue from scratch, right? We have 4,000 intents, that's multiple turns. You'd have millions, if not tens of millions of dialogue trees you'd have to try and create. So using machine reading in the beginning to ingest a year's worth of chat logs and to ingest our knowledge base to sort of understand intents and entities and potential solutions is sort of one application of AI in the process. Another is creating that conversational agent that knows what question to ask at which time, so essentially that every dialogue is a unique dialogue versus a linearly programmed or coded dialogue flow. So there's several points of AI used in the creation of that solution, and it takes a while to build. The good news there is we're up and running. We do about 5 million sessions a month, sometimes 4 times, sometimes 6, on Microsoft.com using that virtual agent. And it's starting to deflect 20 to 30% of those questions, which means answering them. It hands off to humans and the others. We've built a dashboard that shows 4.8 million. That's a running monthly view. You can look in and see where is the dialogue having issues. So when we don't solve a problem and we hand off to a human, why? We found some interesting cases along the way. We're at the point where we've built tool sets so we can work with HP on this. We work with Macy's, a retailer in the US, DHS in Australia, so we're starting to work with others in terms of how to build and deploy it. You find some interesting patterns. So on the Macy's one of the things they were seeing is when people would ask the virtual agent for shipping, like, hey, how do I sort of find my package that's in shipment, it would say, well, go to let's just say the UPS site, I don't remember which site it was, but the shipping site, and enter your number, here's your number. And from there, the person would pop out and go and ask for a human agent. And that's sort of okay. So what we found is the human agent then, instead of saying go to let's say the UPS site, they'd give the URL for it, and the number, often done. And so you learn that, and then you can go back and manually adjust the dialogue flow or the tools and adjust as you go. So there's this nice marriage of a tool set for helping make it smarter over time, learning as you go, and building these virtual agents. That's probably the most used pattern we see today, cognitive service plus a conversational front end on a starting point. But all of them are good starting points. Here's a video on HP's use.
We are selling a product, we are selling also the excellence in support and services.
Customer support and customer service is a huge priority to the company. We have over 600 million contacts per year. Microsoft's advanced AI gave us an opportunity to look at better ways that we could scale. The virtual agent that's guiding them and answering their questions, trying to get the proper context around what the issue is. If the virtual assistant can't solve their problem, that information is automatically passed to a live agent so they can continue the conversation.
Artificial intelligence may be able to boost significantly the productivity of our agent.
It's going to cut down on call handle times. It's going to cut down on the actual overall wait for the customer.
The dashboard is critical. We're able to understand direct customer feedback, see key metrics around how the system is performing and whether or not it's resolving customer problems.
We were addressing maybe 15 to 20% of issues. We're now expanding that to close to 70 or 80% with artificial intelligence.
Microsoft's advanced AI capabilities is a win for any organization. And the platform that they are delivering allows you to get the scale and capabilities that are needed in order to implement AI in your business. We're looking at what other areas that we can apply this technology throughout our ecosystem as part of our digital transformation.
Give me a tool that allows me to say yes definitively and effectively, this is going to fix your problem. Bring it on, let's do this right now.
So a scenario in the making. One of the things we've looked at is what are the horizontal scenarios that many organizations sort of live and breathe on today: customer care, forecasting, the retail environment's got them, manufacturing. So we're looking at these horizontal scenarios and starting to stitch them together. And ultimately, when I end up speaking with customers, there's sort of three things, which is somewhere along the line, it's good to have developers starting to play with the cognitive services and conversational interfaces, whether it's for an agent or for other reasons, because those are going to become more prominent over time. And again, this is sort of vendor agnostic. Just start to play in that area. We have tools to work with, and they're at the point now where they can really be used. The second is if you have unique data assets, right, with your data scientists, go look for an area to focus on and try and figure out how to take the unique asset there and bring it to life in a way that's adding value and is fairly unique. There's a challenge today where people want to apply AI to everything. It's too early for that. It's also too late to do nothing. And so finding the right sweet spot. And then if you feel really good about your team, or you're an ISV, or you're in the business and you want to pick a solution area, then pick one of the solution areas, either by industry or by horizontal, and go deep and try and stitch the pieces together. Now that's the work we've been doing. The last piece I'd focus on in the conversation is sort of the broader conversation on AI, right? We've got sort of infusing it into products and building the platform, building solutions, but there's a broader context for how AI gets used. And that is an area where we're investing an incredible amount of energy, sort of as a company, and trying to sort of lead with the industry. At the end of the day, the conversations and questions that come up about AI sort of won't be led by any one company or any one government or any particular part of society. It's going to take everyone. And so we're trying to be proactive in those conversations. We are focusing on sort of AI for good. Where can it be applied that's beyond the things that are the business-oriented work that we all do, so people can see the possibility. You saw that with the Seeing AI video. We've got a video go look up called Project Emma around Parkinson's. This is a video that talks about the work we're doing. It's called AI for Earth. And so what are projects and investments we can make to sort of think about the planet overall and how to apply AI to helping on the planet and sort of helping with global, in this particular case, global warming, but other areas as well. And so let me go ahead and show you that.
Guggenheimer is a hydropower company located in the south of Norway. We have been basically running the same operation for decades.
The fourth industrial revolution is about connecting things together. We now can collect data from millions of sensors in our systems, in our grid, in our production, and we can use this data to make new products, take decisions, and manage our business.
The Smart Grid pilot program that we did with Microsoft was looking into the grid and see how could we use new technology to operate the grid in a new way. And what we found was that we could actually interact with the customers in order to reduce the load on specific components in the grid. We need to be prepared for what's coming. And to do that, we would need better tools than we have today. And that has to be based on artificial intelligence.
Singapore is a very warm climate country. And GTC has a lot of buildings. With air conditioning, your cost is very, very high.
JOPS is an Internet of Things system that seeks to leverage technology, gather all the building data, do some analysis, and ensure that our buildings are efficient. Within this project, we are able to achieve 15% in energy cost avoidance. We also saw an improvement of 15% for productivity.
I think as a government agency, We set the tone. We believe in environmental sustainability.
The purpose of the yield is to feed the world without wrecking the planet. We use real-time weather data at the farm, and then it goes into Microsoft's Azure cloud, where we apply our machine learning that help growers know when to plant, when to irrigate, and when to harvest. Houston's Farm estimate that they save 30% of their irrigation costs and water losses through using our technology. Climate change is making weather more and more unpredictable. We can't control Mother Nature, but we can use technology to help understand her moods.
So as I think about that sort of next generation, sort of growing up with these new tool sets, while there are, change always drives some opportunity and some concern, and there is, legitimate concern around sort of what is AI, how does it operate. At the same time, there should be, a lot of hope relative to what it can do, whether it's in the medical space, whether it's farming. You pick the industry and you pick the area. AI for good is an example of trying to apply it directly into sort of how we think about the planet. Another conversation that leads from that is sort of the ethics of AI. And one of the things we've been trying to do is be proactive in this conversation. Our head of research and our sort of legal counsel and president published a book. It's available down in our stand. It's a forward-looking book around AI and the ethics of AI. One of the things we have to do is start that conversation, again, at the society level, at the government level, at the industry level, and have a set of ethics, accountability, transparency, so it's not a black box, removing or guarding against bias. So whether these are perfect or not, the goal is to get the conversation started. We think about these as we're building solutions and products. We have people who are in charge of ethics on the team. And the goal here is to sort of be proactive as we go forward, because there again, this is a new area. And with any new area, and people talk about the fourth industrial revolution, there's nervousness in some areas. It's not well understood. It will drive some change. So how do we get ahead of that, both in terms of conversation and then ultimately actions? And so whether it's sort of AI for Earth or the ethics of AI, I think as you think about the conference here today and we think about a global conversation, this is an area that I think we'll all need to sort of, we use the term lean in, but sort of get involved in the conversation and help shape it. And as I look forward, I have a 19 and a 20-year-old, so how do they in that next generation coming out of sort of university or not university, but start to work with these building blocks and apply them to the challenges they'll see, not tomorrow or the next year, but in the next 10 years, the next 20 years. And how do we collectively help assist them? If you want to learn more, akams.ai day, you can always hit me up on Twitter at Stephen Guggs, email, Microsoft.com/AI, any of the information that's here and the rest. And with that, I sort of end my moment or end my time. I appreciate your time this morning.